Today we are going to solve quadratics using the quadratic formula. We are still working with these awesome quadratics that make beautiful parabolas. And when we solve quadratics, we are looking for those x-intercepts, those solutions, those roots, those zeros, so many names that mean the same thing. And so in Algebra 1, you talk and learn about quadratics quite extensively, and you learn all the ways to solve quadratics. You probably have started off with graphing them and visually looking for those x-intercepts. You can also solve using square roots because we have x squareds in them, so you can undo them with the squareds. They're solved by factoring, they're solved by completing the square, there's lots of methods for solving quadratics. However, in Algebra 2, the reason we talk about quadratics again is piggybacking off our last lesson. They're going to have imaginaries in them. So the only way you're going to be able to solve a quadratic that has imaginary solutions is using the quadratic formula, okay? So the quadratic formula can be used to find solutions, zeros, roots, x-intercepts, all that means the same thing for any quadratic function. So that's why we're just going to focus on solving using the quadratic formula, because it's going to work for any quadratic. And for us in Algebra 2, it's going to cover the imaginaries. So I promise you, 1,000%, when we see a quadratic on Algebra 2's end of course test benchmarks, there's no other reason for them to ask us about a quadratic unless it has imaginary solutions. So just expect that. 99% of the time, your quadratic is going to have imaginary solutions. So we are going to use the quadratic formula, which is big and gorgeous and beautiful. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So a couple things here. Make sure in your square root is all of b squared and minus 4ac. All of that is under the radical. And then it's all divided by 2a. Some of my students think, oh, it's just division at the end or part of it. No, all of it is divided by 2a. It sounds like a mouthful, but the more you use it, the shorter the formula seems. I did put on here, you must memorize your quadratic formula. So when we take our end of course test, we are given a lovely reference sheet, a formula sheet, and guess what's not on there? The quadratic formula. So if you don't already know it, you need to memorize it because it will not be on our reference sheet. You also have a mention here that a function has to be in that standard form, y equals ax squared plus bx plus c, to use quadratic formula. That way you can pull out your a, your b, and your c to put it in your formula. I put some steps on here. Make sure it's set equal to 0. Then you can identify a, b, and c. If you're missing one of those terms, you don't have a number, then you use 0, and then you plug it in your formula and solve. We are not going to have decimal answers. We know how to simplify radicals. We know how to deal with imaginaries. So you will leave it in a radical form. So let's dive in. Number 1, you can see it is not set equal to 0. So I'm going to need to subtract 4x before we begin. X squared minus 4x plus 29 equals 0. This is my ax squared plus bx plus c. So my a is 1. There's an understood 1 there. B is negative 4, and c is 29. All right. Negative b plus or minus the square root of b squared minus 4ac all over 2a is your quadratic formula, and let's plug it in. We have a negative b. Whoa. B is negative, so watch out there. A negative b plus or minus the square root of negative b squared minus 4. And all of this is multiplied together. The negative 4, the a, and the c all get multiplied together. All over 2a, 2 times 1. All right. I recommend not trying to throw that all in a calculator because there's too many pieces. Definitely recommend writing it down, simplifying a lot of it by hand, because here we go, negative 4, that's positive 4, plus or minus the square root of, b was negative, and I'm going to square it. Right here, inside the radical where you have b squared should always be a positive number. So make sure negative 4 squared is positive 16. And then I'm going to multiply negative 4 times 1 times 29 on my calculator. Gives me negative 116 or minus 116 all over 2. 4 plus or minus, let's do 16 minus 116 is negative 100. Ooh, over 2. And keep going. Do you see it? We got a negative under the radical, so this is imaginary. We've got the square root of 100, perfect square. We can do this. 4 plus or minus. I'm going to show all my steps because this is our notes. I'm going to separate it so you can see that I'm getting an imaginary. The square root of negative 1 is imaginary. The square root of 100 is 10. This is 10i over 2. And you've done a wonderful job. The last thing you need to check for and complete is if you can simplify these 3 numbers, you must. You are required. So 4, 10, and 2, if you can simplify them, they all can be divided by 2. Let me add that on our notes. I'm going to divide all of these by 2 so that our final answer is 2 plus or minus 5i. I don't need to show it divided by 1, so I'm just going to leave that 2 plus or minus 5i. On Delta Math, there is a plus or minus button that you can use, or you could list them both. You could have 2 plus 5i. There is 2 answers here, and 2 minus 5i is also an equivalent form of the final answer. There are 2 answers there. There is 2 x-intercepts, except they're imaginary, and we can't graph them on a real coordinate plane. So number 2, let's try it again. Again, it's not equal to 0, so I'm going to add 32x. 2x squared plus 32x. Make sure you put it in the right order so you can pull out your a, b, and c. This is ax squared plus bx plus c. My a is 2, b is 32, and c is 144. Quadratic formula, negative b plus or minus the square root, b squared minus 4ac all over 2a. I've got attached on your Delta Math my favorite quadratic formula song to help you remember. That's how I memorized it, was that YouTube video. Check it out. It's pretty humorous. A negative 32 plus or minus the square root of 32 squared minus 4 times a times c all over 2a, 2 times 2. Let me use a different color so we don't run into the other problem. We've got negative 32 plus or minus the square root of 32 squared, 1,024. I'm going to multiply negative 4 times 2 times 144. Gives me negative 1,152 over 4. Keep cleaning up by hand is my recommendation. We've got 1,024 minus 1,152, a negative 128 over 4. Okay, so let's pull everything we've talked about so far and keep simplifying this radical. We've got negative 32 plus or minus the square root of, definitely have a negative 1 in my radical. And then what can I break down positive 128 into? So I want to find perfect square factors. Divided by 4 is 32. That seems good, but I think I can go bigger. 128 divided by 9 is no good. That's no good. 128 divided by 16 is 8, but look, inside 8 is a 4 hiding, so we can go bigger. 128 divided by 25 is not going to work. 36 is not going to work. 49 is not going to work. 8 times 8 is 64. Aha! 64 and 2. 64 and 2 over 4. So let's clean up those radicals. A negative 32 plus or minus, I've got an I, I've got an 8. That makes 8i, radical 2 over 4. If you can, you must simplify these numbers together. And we can, so we will. It looks like they are all divisible by 4. They're not always this like divisible by the denominator, so just make sure you check for a common factor. So we'll have negative 8 plus or minus 2i radical 2 over 1. I don't need over 1. Negative 8 plus or minus 2i radical 2. I have one more, and then we're going to go to page 2 and talk about something else. It is also not set equal to 0, so subtract 36x from both sides. It's just the way all the Delta math problems were set up. So sorry. I wish I could give you more variety. All right, so ax squared plus bx plus c. So my a is 4, my b is negative 36, and my c is 85. And we're plugging into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I've got a negative 36 plus or minus the square root of negative 36 squared minus 4 times 4 times 85 all over 2 times 4. Two negatives make a positive 36 plus or minus the square root of, now again, b was negative. When I go to square b, it's going to be a positive number every time. So negative 36 squared is positive 1,296. I'm going to multiply negative 4 times 85. Gave me negative 1,360. All over 2 times 4 is 8. 36 plus or minus the square root of what is 1296 minus 1360. A negative 64, like that. So let me show all my steps. We've got a negative in my radical and a 64. The negative is your imaginary, 64 is 8. So 36 plus or minus 8i over 8. Oh, so this is one that they're not all divisible by 8, not divisible by our denominator. 36 and 8. 8 does not go into 36. But I can divide them all by 4 and at least reduce them, these 3. So that'll give me 9 plus or minus 2i over 2. All right, the second page of our notes is the discriminant. And bless its heart, the discriminant, it's helpful, but not that often, so we forget about it. We don't use it enough. But I can guarantee you there will be one question on a benchmark on your end of course that's going to ask you about types of solutions. So the discriminant, I'm not making you learn a new formula. It's just the expression under the radical sign in our quadratic formula. So just the b squared minus 4ac is the discriminant. Not a whole new formula, just the piece under the radical. That number, when you plug that in, the number you get will tell you the type of solution that you have. If you have 2 real solutions, 2 imaginary, or 1 real solution. I made this table for you. So let's look at that. When your discriminant value is negative, you plug it into b squared minus 4ac and it's less than 0. It's a negative number. Then you have imaginary solutions. That's all a discriminant does. It just tells you the type of solution that you have. Let's say you plug in your values to the discriminant and it comes out as 0. You plug into b squared minus 4ac and it is 0. Then you're going to have real number solutions and they are going to be equal values. If you plug into your discriminant and you get some positive number, you plug into b squared minus 4ac and you get 85. You get 121. I don't know. Then you are going to have real number solutions, but they're going to be unequal. So let's say you got the square root, you got 121 as your discriminant value. The square root of 121 is actually positive and negative 11. So even if it's a perfect square, They are unequal because one is positive and one is negative, but they're still rational numbers. Let's say you get a non-perfect number. Let's say the square root of 13. It's still a real number, but our answers are going to be unequal because the best we can do is just positive or negative, square root of 13. So they're going to be irrational. The square root of any non-perfect number is irrational. It's a decimal that never ends. So use this table to help you answer your questions on Delta Math. So let's do some together. Number one, for the following quadratic equation, determine the nature of the roots. Here's your full quadratic function in standard form. My A is an understood 1, B is negative 10, and C is 9. And we're plugging it into just B squared minus 4AC. We just want to know what kind of solutions we have. We don't care what the solutions are. Your questions on EOC, it's going to be which quadratic has imaginary solutions. And instead of solving them all out using the quadratic formula, when you don't really need to know what the solutions are, you just need to know which one is imaginary. And more than likely, out of A, B, C, and D, you just solve them all out, and it's going to be the last one. You can just use the discriminant. So if I have negative 10 squared minus 4A minus 4AC, that's going to give me negative 10 squared is 100 minus 36. I can already stop. I know 100 minus 36 is going to be a positive number, but it is 64. So since it's positive, the discriminant value is 64 because it is positive, and it's a perfect square. It's going to be real. They're going to be unequal x-intercepts, but it is rational. This also tells us there are two real solutions. Number 2. My A value on number 2 is another understood 1. My B is 8 and C is 10. So if I do the discriminant, B squared minus 4AC, 8 squared minus 4 times 1 times 10, 64 minus 40. Again, I could probably stop because I know I'm going to get a positive number. We'll have 24. That's my discriminant value. It's not my solution to the quadratics. It's not my roots, but it does tell me what kind of solutions I have. I do have real number solutions. They are unequal, but because 24 is not a perfect square, they are going to be irrational numbers. Because we got a positive, again, two real solutions. Number 3, my A is another understood 1. B is 6 and C is 50. So if I do B squared minus 4AC, 6 squared minus 4 times 1 times 50. 6 times 6 is 36 minus 200. I wonder what it's going to be. A negative number. That's for sure. 36 minus 200. Negative 164. So there's my discriminant value. Because it's a negative, very straightforward, very clear, we are going to have imaginary solutions. And I'm going to star it because this is the one we're going to see on our end of course, because the only types of quadratics that we work with are ones that have imaginaries in Algebra 2. It's the only reason we talk about them. So these are imaginary when they are negative. So instead of having to solve your entire quadratic, so instead of solving your entire quadratic, you can just do the discriminant, and if it's a negative value, imaginary solutions. All right, last one, number 4. Did you see it? we've got to set it equal to 0 first. So subtract 8 from both sides. And then ax squared plus bx plus c. My a is -1, b is 8, and c is -24. So let's do the discriminant. 8 squared minus 4ac. 64 minus 96. Oh, that's going to be a negative. 64 minus 96 is -32. So that means, again, we have imaginary solutions. Whenever you get a negative, you have imaginaries. Okay? And that's solving quadratics with the quadratic formula. Again, there are multiple ways to solve a quadratic. We are going to use the quadratic formula because the quadratic formula is the only way we can solve if there's imaginary solutions. And the only kind of quadratics they're going to ask us in Algebra 2 are ones with imaginaries, because in Algebra 2, you learn about imaginaries. So just learn your quadratic formula. Just be prepared to use it anytime you're asked to solve a quadratic. Bust out the quadratic formula. And then we talked about the discriminant. Be watching for those negatives. When you plug in the discriminant, b squared minus 4ac, almost expect it to equal a negative, because there again, it means there's imaginary solutions. And the only reason they would ask us to do this in Algebra 2 is if there's imaginaries. So hopefully you see how that's coming together. If you have questions, please let me know, and I'll see you in class.